Welcome back to the bench. We have for you today a kit build, and this is a kit that costs sub €5. This one cost €2.62, and this came from Find Yours on eBay, and I'll put in the copy of the eBay ad here so that you can find it. Okay, so we have our display. It's just 3 digits, some croc clips, our microcontroller, which is an ATmega 8L-8PU, some resistors, pots, transistors, feud caps, a diode, and a bit of hardware, and quite a compact little PCB here. Components mounted on both sides. So yeah, it's going to be the CPU on the back and display on the front, and we're going to have to put the chip socket on there first before we put in the display, because otherwise we're not going to be able to solder the chip on. So 10K, 110K, and then the rest look like 220 ohms, so that's going to be these ones. These are going to be our current limiting resistors for the display. U1, yeah. So, yep, pretty straightforward. Probably do the resistors first. Bring it all with a bit of foam, and chop the ends off our resistors. Let's get some sharper cutters. These ones are a little bit dull. So we'll put in our 220 ohms. First of all, so our resistors soldered onto that side of the board. We'll do the other low level components on this side. We've got one 220 ohm left, which goes into there. Okay, now we've got 2 other resistors here. One of them is going to be a 10K and the other is a 110K. Now these have very similar colour markings. So we've got brown, black, black, brown, and like brown, brown, black, orange, which should in theory be our 110 ohm. Or 110K, I should say, wasn't it? Yeah, 110K. But let's be sure, just be on the safe side. So what I'm doing is I'll bring in, this is a little component tester. It'll test transistors, capacitors, diodes, and various other items. Very, very handy, especially if you just want to quickly check the value of a resistor or a capacitor, especially chronic ones if they're not marked. You can find these on eBay for about €10. Okay, so that's a resistor, it says, and yep, that one is 10K. Oh, near enough. Yep. And this is the one that had the orange stripe, which I assume is, or assumed would be the 110K. And we can just confirm that. Oh no, no damage device. That's because we're putting them both in 1 and 1. Dull. Nope, still doesn't like it. For some reason it doesn't like that resistor. The legs on this are very, very thin, so it could be that it's not being gripped in the socket properly. Let's try and just put a bit of pressure on it. Yep, there we go. And that's 110k. Okay, so that's all our resistors done. I'd say do the diodes and the ceramics next, or the diode. There's only one of them. Okay, so we've got a JST connector, potentiometer, transistor, switch. Let's go for the transistor. Okay, so all that's left now is the IC sockets and, oh, there should be a resistor network, should there? And we have a part missing. Back to the eBay listing. Nope, there's nothing missing from there. It must be from a different revision of a board, maybe. Who knows? Or it might just be vias to go from the top side to the bottom, but there's nothing really on this side. Okay, so what I thought was a transistor U2, looking at the circuit diagram, which is on eBay, that's probably some kind of voltage reference. I did notice that the DETMAL chip does not have a crystal. So obviously it's using some kind of internal RC clock, so yeah, it probably doesn't need any kind of precision timing. That's our chip socket soldered on there. So the display next. It's got quite long legs, so it's going to need to, because it's got to sit above all these other component legs. So according to the silk screen, it should go on this way. Pop our chip in, make sure we put it in the right way. And that's a little bit too wide. I'll just bend those legs in a little bit. I'll do the other side as well. Tight fit in that socket, but we're in. Okay, last thing to do is to solder the wires onto these crocodile clips. take to cool down. Well, there's actually only one input onto this board, which is the J1 connector. So this little voltmeter must be self-powered, so it's not so much of a voltmeter, but just a voltage tester. So if you want to know the line voltage or something, you just plug it in. I have a 9-volt battery here. That's negative. And here's our positive. And nothing happened. Now try putting the switch in. Okay, so we've got a non-sickle reading. So not all the segments are lining up. It looks like it should be saying 10.2. Let's try it on some 18650s. Yeah, that's great. I broke the connection off. It's scrap anyway. So we have our negative down here. And our positive up here. Let's pull these wires apart a bit further, otherwise we're just going to get tangled up. And there's probably not enough juice in this to actually turn it on. Oh yeah, there we go. Yeah, 4.2. That's about right. But not all our segments are working. I think I've probably got a solder joint between two of the connections there by the looks of it. Yeah, I've got a solder bridge in there. Yep. So let's try a 9-volt battery again. There we are, and it's working perfectly. So 10.2 volts, that's probably about right without a load on this battery, because it is actually a rechargeable. So it might be higher, a little bit higher than the 9 volts stated. Let's put it on our meter. No, it says 9.2, so yeah. I'm guessing that's what then the adjuster is for on this, so that you can calibrate it. Can we get this to stay on here long enough to be able to calibrate it? Okay, 10.2, get a driver. So this battery was showing 9.2. That's going the wrong way. Let's take it down. Okay, so now that's given us 9.2, which is what my big meter says. So we try the 18650s again. Oh, yeah, it's fluctuating a bit. I don't think there's quite enough power to keep this thing running, or it's a bad connection. 3.9. That's what it's saying, and our big meter is saying 4.1. That was 3.94, so yeah, it's a little bit out. I don't think it's going to be any good at measuring alkaline batteries. I don't think there's going to be enough juice in the battery to power the circuit and do the measurements. But we see, yeah. So maybe with 2 batteries, 3.4. Let's try that like that. Yeah, 2.9, so that's quite a bit out. Let's say 9.25. That says 9.2, so that's pretty close for that. For other sizes, the lower you go, the more out it goes. So you really need to calibrate it for the size of battery you're using, which makes it pretty useless. I mean, this is not a serious voltmeter anyway. Let's remove the protective cover off there. I mean, it's literally is just a gimmick. It's just a toy. You know, it cost a few euros. You know, if you want to practice building little kits, you know, and you just want to have a bit of fun, just playing around, not really sure what you're doing, you can't really go wrong with the price. I mean, if you put it together and it doesn't work or it goes pop, then yeah, you haven't really lost much, have you? A couple of euros. You know, if it works, bit of fun. You can always just hook this up to a battery and quickly test the voltage without having to drag out the big meter. Or if you don't have a big meter, just get a rough idea if there's any charge in the battery. Yeah, and because it's actually powered from the battery, it should give a reasonable reading because it's actually putting a load on the battery. You really shouldn't test a battery with a voltmeter because it won't give you the right reading, because you know, it needs to be under load. Because yeah, without a load on it, it could tell you that it's like this 9 volts, but once you start putting a little bit of load, that could drop sharply down to like 4 volts if it's relatively discharged, because it will gain a bit of voltage back, but you know, very little current if it's left alone. So I hope you enjoyed that little kit assembly video. If you did, then please, you know, obviously subscribe, ring the bell icon, and yep, I will see you next time. Thank you for watching.